Hello my science friends, how is your journey to the Wright Brothers Genius Academy going? Let me tell you about an experience I had that forever changed my perception of innovation and creativity. Back in my days at the Academy as a student, I met Professor Miss Abby, an eccentric and creative inventor who had unique ways of explaining physical phenomena. In one of her demonstrations, Miss Abby dropped a rock from a cliff onto a watermelon below. When the rock hit, it smashed the watermelon. This impressive demonstration explained how energy transfers between objects, illustrating the interaction between gravitational and kinetic energy. A Newton's pendulum is a tool that helps us visualize how energy is transferred from one object to another. It consists in a series of hanging and aligned spheres connected in such a way that we can clearly observe the energy transfer. When you lift one sphere and let it go, the kinetic energy of the moving sphere transfers to the resting spheres. This illustrates the principle that energy cannot be created or destroyed, but is instead transferred from one object to another. For this experiment, we'll need a large piece of cardboard, a pen, 2 wooden skewers, a ruler, 6 small balls, scissors, string. First, we'll make the base. Mark a rectangular shape on the cardboard, 10 centimeters wide and 24 centimeters long. Now, let's do the same with another piece of cardboard, but this time the size will be 20 by 25 centimeters. Then, cut out the rectangle. On the 20 by 25 centimeter cardboard, we'll make a U shape. Start by marking 2 points. 7 centimeters from the 20 centimeter side along the 25 centimeter edge. These will be your first reference points. Next, mark 2 internal points, 5 centimeters away from the first ones. Finally, mark 2 points 5 centimeters from the 25 centimeter edge. These will form the base of the U. Repeat this process to make 2 U-shaped pieces of cardboard. Now, take the 10 by 24 centimeter rectangle and mark 2 straight lines. One set 3 centimeters from the 10 centimeter side, and another 6 centimeters from the 24 centimeter side. Cut along these lines to create grooves. Attach the U-shaped pieces to the grooves on the rectangular base using hot glue. Next, use a skewer to poke a small hole 1 centimeter below the ends of each pillar. Insert the skewers between the pillars and secure them with glue. Cut the string into 6 equal pieces, each 30 centimeters long, and attach a small ball to the middle of each string. Repeat this for all 6 strings, ensuring they're all the same length. Tie the strings to the skewers so the balls hang exactly in the middle. Make sure they touch each other and are at the same height. If they don't align, adjust them until they're perfect. Once your pendulum is set up, lift one of the balls and let it go. Watch how the energy transfers and how the ball on the opposite end moves. Science in action! It's challenge time! Let's see who can keep their pendulum in motion the longest. The key is in the precision of lifting and releasing the spheres. Good luck! Newton's pendulum is a brilliant example of energy conservation and how kinetic energy transfers from one object to another. By observing these spheres, we can clearly see both these phenomena at work. And that's it for today. I hope you enjoyed building and experimenting with Newton's pendulum. Remember, energy transfer is key to understanding many physical phenomena. See you in the next episode for more scientific adventures.